Hello, friends. This is a podcast to introduce Section 14.2, inference for two-way tables, also called chi-squared test for homogeneity or chi-squared test for independence. This is our final section of the year. We're going to do this activity, 14b, in class tomorrow. So I would like everyone to email me back right now their opinion on whether or not they think marijuana should be legalized. And what we're going to do is a chi-squared test tomorrow to see if there is a difference between males and females on this issue. So we'll do that in class. So please email me so I can have the totals for all 23 students in AP Stats tomorrow. You should recall that during the last two classes where we did chi-squared tests for goodness of fit, that we generated some chi-squared numbers by comparing observed counts to expected counts using this formula of squaring divided by the expected counts and getting a chi-squared statistic. And with the chi-squared statistic, we generated a p-value from these chi-squared distributions. And the p-value came from the area under a chi-squared curve, which was a skewed curve. And we interpreted p-value the exact same way that we have been for all these inference tests. For this next set, the chi-squared test for homogeneity or the chi-squared test for independence, which are really the same thing, and the book rightly calls it just inference for two-way tables. Here's our two-way table, and you should recall from chapter 4 that this entire thing is a two-way table. This is the body, in other words, the counts that were recorded, and you should be able to read in this example that for example, while French music was playing, exactly one bottle of Italian wine was sold. So read this example. We're comparing, is there a difference in how many bottles of wine from different countries are sold based on what music is playing in the store at the time? So I do digress. This is a two-way table, and these are column totals. These are row totals. And we said that marginal distributions are when we take a column total and divide it by the grand total. And that gives us a marginal because it happens in the margin. So we could get the percentage of all bottles of wine that were purchased when no music was playing. And we could also get a marginal distribution of how many bottles of French wine were sold out of all the bottles sold. And that would be a marginal distribution. Conditional distributions were when we looked at one category. So in other words, out of all the French wine sold, which is 75 bottles, all the bottles that were sold while the French music was playing, I should say, that's 75 bottles, 39 were French. So I could get a conditional distribution of how many bottles of wine of each country were sold while the French music was playing. So to get that, I do 39 divided by 75. And by doing those conditional distributions, I can then convert all those counts into percents, which allows me to compare categories with different totals. So now I have the percent of each type of wine that was sold out of all the ones that were sold when there was no music, when there was French music, and when there was Italian music. And now these are all percents. And from these percents, which are the conditional probabilities, the marginal probabilities of what wine was sold for each type of music, I can make a graph so I can get a visual. Is there a difference? And if I did them the other way, I could get a look at what kind of music was playing when a particular type of wine was sold. So this tells me French wine, what percent was bought with no music, with French music, with Italian music. So I should be able to take a two-way table like this, make it into percents, and I should be able to make and interpret graphs. Again, the calculator and the spreadsheet will do all this for you. So this is just by way of understanding what the two-way table is, and we'll go through actually the chi-squared procedures in the next podcast.